Awesome. Good afternoon, student. Is the screen visible to you? Yes or no? Am I audible?
Yes, now you're audible.
Okay, so we are done with number system. Permutation and combination was also done. We were about to start with relation. Na? In that,
Yes.
I did explain you. Logic was also done.
Yes.
So in relation, we just started it, right? We explained Cartesian product and then relation. See, I can remember this milk cows. This was also done. This part, types of relation. Did we discuss this relation, types of relations?
Yes, ma'am. Yes.
Okay, so this is also done. So we have to start. No, reflexive relation is also done.
Hello, your audio is not visible. Sorry, can't hear you.
Okay. Am I audible now properly?
Yes. No.
Okay. So we are done with this relation unit also, right? Matrix is also done. I can remember now. 0, 0, 1. Closure is also done.
No. The matrix was just a bit you taken on it.
See, dear, closure. See, now I can remember. Closure also we discussed. What is the difference between normal reflexive relation and closure? Closure is nothing but smallest relations of all.
Smallest division.
Yeah.
Yes.
So we were about to start with functions then.
Function.
Okay. So when we talk about function, it is represented in which form? Let's say f is a function going from a to b, where a is called as domain. This is called as C. A is called as domain. B is called as codomain of the function. Now here the symbols are missing up. It is in this form. F is from A to B. This is how you are going to read it. And how do we represent? If I am talking about AB, let's go from your textbook. It is in terms of x and y. So your function is from x tends to y. So it will be represented in which form? Y equals to f of x in this form. What do you understand from this? Or else, if you want to keep in mind, your function is from what? X to y. So function is for what? X, and you get the value of y. Understood? And this small x belongs to capital X, small y belongs to capital Y. So x becomes your domain and y becomes your codomain. Now range is what? Range is nothing but, let's say you have some images. For example, wait a minute. See, this is x and this is y. So whatever the elements present in y, small elements who has pre-image over here, they are all the ranges. So let's say you have 1, 2, 3. So your 2 and 3 has images to the x. So your range is 2 and 3. Understood? See, let's take this example. A is given 3, 5, 8, 15 and B is a 5, 10, 15. Now your order pair will be what? 3, 5, 5, 5, 8, 15. They have given us this. This whole thing is given to us. Then f is a relation from set A to B such that, how is it given to us? Now see, f of 3 will give me 5. F of 5 will give me 5. F of 8 will give me 15 and f of 15 will give me 15. Now you can understand 3, 5, 8 and 15 are what? What are those? X na? So they are from the domain part. Then you can understand 5, 5, 15 and 15. What are those elements from B
Codomain.
part? Correct. That is the codomain part. So therefore, that is a function. Now your range will be what? The images which you have gotten. So images are either 5 or 15. So those becomes your range. This will be your codomain and this will be your domain. See, domain is the same, codomain is the whole, but range differs. The images only na. Whatever the image you get into the A part, only those they have to take. Understood? Codomain, domain and range. Now let's talk about types of functions. So there are two types of functions. The first one is one and the second one is onto functions. Now one function means it is also called as injective function. What happens over here? Let's say your function is from x to y. So what will happen over here? Whatever the elements are there in x should always have uniquely defined images. Means here, if this one goes to this part, it's not allowed. Only one. You can understand by the term one function. So that means elements from all x should have images in y. See, let me read it out. A function f of a, f from a to b is said to be an injective function if distinct elements, see, unique and distinct means same, of A have distinct images in B under F. Therefore, it is called as one function. Now, after that, let's talk about onto functions. Now, what happens in onto functions? All of the images present in Y should have free images. Means the formula for this is for all Y belonging to capital Y, there exists X which belongs to capital X. Means all the elements in Y should have free images. Compulsion. Maybe one is going to 2, it's no problem. But it means, let's say if you have one as a single, it does not have free image, then it is not a onto function. Understood? Let me show you over here. A function f from a to b is said to be an surjective function if C, every element of set B has at least one pre-image in set A. That is what I told you. And after this is bijective functions. Now bijective, by the term, bi means what? 2. So bijective functions are those who has injective and surjective both. Means they are one as well as they are onto functions. Should we take an example? Let's take this one. Where is the formula for that? Okay, you have inverse function also. Now, inverse functions, first condition for being an inverse function is that it should be a bijection function. Means it should be 1, 1 and on 2. Compulsion. Then only it will become a inverse function. And see, these two dots are nothing but f. So it is f tends to, then single dots, a tends to b. And here it is f inverse. So your inverse function will be written in this form: f inverse b tends to a. So here your b becomes what? Domain, and a becomes your codomain. For what? Only for inverse function. See, first we will just discuss how many functions are there. Till here, did you understand function? So you have which one functions? One function, onto function, and bijective function. And the last one is the inverse function. After that, you have composite functions. Now, composition and multiplication, there's some difference. Normally, if you had 2 into 3, we had multiplication. But when I'm talking about two functions, it is compulsion that you have to use composition. Let's say f dot g I am saying. Let me show you. See, here they are said g dot f. It can be g dot f or it can be f dot g. So this small dot, what is considered is, let's take the below example. 1, 2, if your a is 1, 2, 3, b is also given, and f is a function from a to b, such that f of 1 is equals to what? 15. F of 2 equals to 23. And what? Do we have to find something? Okay. So we have to just cross check it now. So you need to find g dot of f. So f is from what? A to b, correct? So you can see this one, double dots are what? F. So f of 1 is what? 15. You need to find, define it, that g of 5 should be 7. Let's take first one, g dot f1. Or should I say g composite f. So your g function will be as it is. Instead of x, we are going to write f of x value. Now, if I have to write f of, let's say 1. So f of 1 is what? 15. So you need to find g of 15. Understood? Because f of 1 value is 15. Check over here. So g of 15 is what? 17. Understood? This is how you are going to solve the problems. For this, kindly refer to your 11th and 12th textbooks for proper understanding. It's there in your 11th textbook also, in part 2, maths, science side. Now, after this, you have topic vectors. Now, vectors are what? It is a physical quantity. It has directions. There are two types, vectors and magnitude. Magnitude doesn't have any direction, but here vectors have directions also. We all studied in physics as well as in maths. See, if I am writing AB, I'm not just writing AB, it is having a sign also. It is going towards what? Right side, na? So this becomes my vector. A vector is a geometric object that has both Magnitude is also there, means distance is also there, or length, that only. And direction. A vector is frequently represented by a directed line segment by an arrow, the above part. A directed line segment AB with an initial point A and with a terminal point B represents vector AB. The magnitude or modulus of the vector. Now see, the magnitude is what? Length of the segment, and it is denoted in this formula. This means magnitude, the lines which are drawn besides AB. Now we need to study types of vectors. There is equal vectors, the vectors having same magnitude and same direction. Then they are called as equal vectors. Means here A is giving me the same direction as B. So A and B are equal vectors. Unique vector means what? A vector whose magnitude is 1. Magnitude means this part is 1. And it is represented by A kappa. So it is A cap in this form. And the formula for that is A cap equals to A vector upon magnitude of A vector. After that, zero vector means just a point. Should I say a point? A vector whose magnitude is 0 unit is said to be unit vector. Obviously, for a zero vector, the initial point and the terminal point coincide. So you can understand just a single point, because initial and terminal point are coinciding on each other. After that, collinear vectors. Vectors which are parallel to the same line are called collinear vectors. Now see, in A and B, both are parallel, na? So A and B become collinear vector, as well as C and D, because they are not going to touch each other or intersect each other at all. It is just joining to each other. So they also become a collinear vectors. Now coplanar vectors. Vectors which are lying in the same plane or in the parallel planes are called as coplanar vectors. Now negative of a vector, or C, a vector having the same magnitude but opposite direction. C, A, B, both are in same distance, but A is going towards left and B is going towards B. Sorry, B is going towards right. So the direction is different. So therefore they become a negative vector. Now algebra of vectors. Normally when a new term is introduced, you need to find its addition, subtraction, multiplication and so on. Now when we are talking about vectors, addition of vectors, here we are going to use which law? Triangle law. Means if two vectors are such that the initial point of the second vector is the terminal point of the first vector, means in this form. If the initial point of the second vector is the terminal point of the first vector, then triangle law of vector addition is used. So when we are going to use it, can I say it is in this phase? That is, they are both collinear vectors. Then I am going to use which law? Triangle law. So O, A, B are 3 points such that OA equals to A vector B and OB. So OB equals to OA plus AB. So C is equals to A plus B. See, you can see over here. Here also is the same thing. Now, OA. This is my terminal point, but it is the initial vector for AB. See, this was regarding the collinear points. Now, what if they are not collinear? See, this is the condition. They are not collinear, na? Because at some point they are going to intersect. You can see it. So for that we are going to use this one. See, OA is what? A. AB is B. And VO is C. Now parallelogram of law of vector addition. If two vectors are such that initial point of first vector as is same as the initial point of second vector, then parallelogram law of vector addition is used for the addition. You can see from here. Initial point for two of these vectors are same, correct? Let's see the law. O, A, B, and C are 4 points such that OA, OB are adjacent side of parallelogram. Then diagonal through common initial point. This diagonal represents what? OA plus OB. So OC will be what? OA plus OB. That is C equals to A plus B. That is what parallelogram law of addition. Now properties of addition of vectors. Additions are always commutative, means A vector plus B vector equals to B plus A vector. Same way, it is associative, means one more term is included. A plus B plus C equals to A plus B and then plus C. For any vector A, identity. See, this is what identity, because A plus 0, 0 plus A gives me A only. So this becomes my identity. And negative vector is also called as the inverse vector. Now subtractions of vectors. For any two vectors A and B, the difference A minus B is defined as A minus B equals to A plus minus B. So minus B is what? Negative vector of A. Can I say that? Yes, I can say that. See, if you're having C, so if your BA is another triangle, okay, so over here you can understand A is this, B is this. So this is in this direction. So this part will be opposite to what? See, the directions are in which form? This one is going in this form and this one will be going to which form? This part. So your A will be what now? See, it is in this form. So this will be same as this because A is there. So A is here. But this is going in this direction and this one is going to this direction. So A minus B. BA is what? A minus B. C. After that, scalar multiplication of vectors. For any vector A and see difference between scalar multiplication and there's one more multiplication is your magnitude is not taken in scalar multiplication. Means a k is introduced. K means what? A scalar product. We know that if I'm saying 4x, your 4 becomes my scalar product of x. For any vector A and any scalar number k, scalar multiplication is defined as k into A. The vectors A and Ka are always collinear. So you have to note these points that vectors A and Ka are always collinear. Also, two collinear vectors are scalar multiples of each other. In the following diagram, A and B both are parallel, we can see, and B is what? Twice of A, na? See, B is twice of A. Same way, P and Q are there, but they are in opposite direction. So P equals to what? Minus half of Q, or else I can say Q is minus of 2P, because direction matters over here. Okay. So property of scalar multiplication. If A and B are any two vectors and M and N are any real numbers, then scalar multiplication of a vector is associative. M associative means again the same part is introduced. Now scalar distributive means M into A plus B equals to M of A plus M of B. Now addition is see, scalar multiplication is distributive. Now addition means what? That part. But difference here is this is just a normal addition and one vector is there. Here I am having two vectors and one scalar multiplication. Representation of a point in plane using vectors. Position vector of a point. If P is any point and O is some fixed point, then the vector OP is called position vector of point P with respect to 0. In particular, if P is a point in plane. Now, representation of a point in plane using a vector. Position vector of a point. Representation of any vectors in terms of position vectors. Then what all is there in this chapter? Then we have products of vectors. There are two types of products. Those are dot products and cross products. What all is there? Collinear vectors and coplanar points. Okay, so let's do this. Okay, position vectors are what? Those which have a notation. Understand that much. Now, representation of any vectors in terms of position vectors. Now, see over here. Let's talk about AB. If I am saying AB is what? As the difference of position of vector B and position of vector A. So AB, it is in this form by triangle law. What do we know? If I am having one initial point, you can see, and it becomes a terminal point of the other one. So OA plus OB equals OA plus AB equals to what? OB. So AB will be OB minus OA. Representation of a vector in plane. Now plane is introduced, and plane is a 2D figure. So P be a point in plane with Cartesian coordinates x and y. Let O denotes the origin in the Cartesian plane, and I and J are unit vectors along x-axis and y-axis. So OQ will be x-axis, OR will be yj. As these two vectors obviously is going towards left and this is going towards upward. So they are not going to intersect to each other. So they are what? Collinear with the unit vectors I and j. So by parallelogram law, see, 2 are the initial. So OP will be what? OQ plus OR. See, OP is what? OQ plus OR, that is xi plus yj. Now magnitude of this vector, so OP bar, so it will be what? Under root of x square plus y square. Same way, If it is a 3D figure, so it will be x square plus y square plus z square. By which formula? By distance formula. Now product of vectors. Earlier we studied addition, scalar multiplication and so on. So the first one is dot product. Here A dot B is given. That is equals to A vector, unit vector of A into unit vector of B, and cos theta is introduced. This is regarding what? Dot product. See, if you need to find AB equals to, so A1 B1 plus A2 B2. Here what happens is I into I equals to 1 and I into J, sorry, here we don't use cross, we use dot. So I into I is 1, so I dot I is 1, I dot J is 0. For any two vectors A and B, the dot products A dot B is scalar. That is a real number. Hence, this product is also referred to as scalar product of vectors. Now, it is commutative. So, AB, A dot B equals to A dot B cos theta equals to B dot A cos theta. Now, any two non-zero vectors A and B are perpendicular. Now, see, here you need to differentiate. In dot product, what happens? If they are perpendicular, then this, what is this now? Here your AB is what? 0. If and only if. This part is what? Cos theta equals to half. And if A and B are two collinear vectors, then in this case, it is either 0 or it is 1. Cos 0 or when do I get value -1? Can anyone tell me? See, for cos 0 is 1. So, if it is here 0 and it is giving me value 1, so here it will be 180 degree. Don't forget about that. So, here your cos theta should be 0 or pi. Don't forget about that. So cos pi gives me value -1. So A dot A equals to A dot A cos 0. So that is A square. If there are many unit vectors along x, y, z axis, then cos of pi by 2 is introduced. So cos of pi by 2 is 90 and cos of 90 is 0. And if you are having I into I into I, j into j into j, see I told you I into j, j into k is always 0. And I into I, j into j, k into k is always 1. Dot product is distributive over vector addition. See A into B plus B into C. Now let's talk about cross product. If A and B are any two vectors and this symbol means what? Sine is the angle between magnitude AB sine theta and which has direction. See, in dot product we didn't have direction, but in sine product we are going to have the direction perpendicular to both A and B. Now n cap denotes unit vector perpendicular to both A and B such that A dot A cross now. A cross it is A cross B. A cross B means magnitude of, see this dot is nothing but kappa because it is a vector. Or line in, I should say. If two position vectors in space are A equals to A1I, A2J, A3K, and B is 1 and 2. So your cross product will be in this form. See, I, J, K, A1, A2, A3, B1, B2, B3. So how do you find? If you neglect first part, that is I. So I will be, see, cut this I, J, K and this part. So it will be A2, B3 minus B2, A3 minus J. Again neglect this part, middle part. So it will be A1, B3 minus A3, B1. Same way round K. So using determinant, it is easy to solve. Now properties of cross product. For any two vectors A and B, their cross product is A cross B is a vector. Hence it is vector product of vectors. Now in cross product, if A cross B is along n, so B cross n is along minus n because it will give me different direction. If A and B are any two vectors which are perpendicular. Now see, sine pi by 2 is giving me 1, na? 0, 1, 0. So sine 90 is 1. And sine, how much is what equals to half? Can anyone tell me? What is the value? Find it out. If A and B are two collinear vectors, then in this case, A cross B equals to 0. When do I get value 0? When sine 0 is 0. Don't forget about it. A cross A into A equals to A into A. Sine 0 is 0. So A cross A is always 0. Now here you can see I into J gives me K. J into I will give me minus K. Now J into K will give me I. See, it is in the sequence. So let's say this is your circle. Here is your I, this is your J, and this is your K. So if you are going in this form, that is I into J give me K, K into I will give me J. If I am saying J into I, so J into I will give me minus K, right? See, where is it? It's not C. J into I. J into I minus K. If it is going in opposite direction, then it will give me minus sign. If it is going in this is called as clockwise direction, right? So if it is in clockwise direction, then you are going to get positive values. Otherwise, negative values. After that, collinear and coplanar vectors. We know collinear vectors means what? They should never meet each other. Correct? So if two or more vectors are parallel to the same line and are along the same line are called collinear vectors. The collinear vectors need not lie on the same line always. Now see, P, Q, R, all of these are collinear vectors as well as A, B and C are also collinear vectors because they are parallel to each other. Now coplanar vectors. If more than if more than two vectors are parallel to the same plane, see, if more than two vectors are parallel to the same plane, are on the same plane. Here, it didn't have the same plane, but here it should be on the same plane, are called coplanar vectors. The coplanar vectors need not lie on the same plane as always. See, in diagram, A, B, C are coplanar vectors. Why are they saying this? Because they are parallel to the same plane. Even if they are intersecting here, but to the plane they are parallel, na? You can see it. But let's talk about P, Q, R. Why are they not coplanar vectors? because they are on the different planes. On different planes, they are parallel. Here, they are parallel on the same plane. See, important properties. Two collinear vectors are scalar multiples of each other. Conversely, the vectors, which are scalar multiples of each other, are always collinear. Two vectors, A and B, are collinear vectors if and only if C. Collinear vectors is there. So, when is this possible? For A cross B, na? See, if they are collinear, then A cross B equals to 0. Two non-zero vectors, A and B, are collinear vectors if and only if there exist two non-zero real numbers k1 and k2 such that they are scalar multiples of each other. Any two parallel or intersecting vectors form a plane, hence they are always coplanar. Three vectors are coplanar if and only if they are scalar multiple. Now scalar triple product means what? A dot B dot C equals to 0. So here you have to introduce cos theta. And cos theta value, when is it 0? It is for pi or pi by 2. It is pi or pi by 2. Can you confirm it? It is for pi by 2. Cos 90 value is 1, 0. Three non-zero vectors A, B, and C are coplanar if and only if there exist real numbers. See, K1 A plus K2 B plus K3 C equals to 0. Understood till here? See, you need to revise it from your 11th standard book. You will understand it properly. Here, few symbols are missing, but as this is your syllabus based PDF, so we are not going to neglect it. From tomorrow's lecture, we can start with matrices. I'm ending the meeting now. Thank you, everyone.
Thank you.